Good evening, everybody. This is Mr. Sheehan, and we're going to go through our notes for today, which are on solving radical equations. So a radical equation, first you need to know what it is. It's any equation with a variable under a radical sign. So that means anything that has a square root of x, a square root of x plus 1, anything like that. Any place that a variable is underneath a square root, a cube root, or anything. So we're going to go through the steps, we'll do a couple of examples, and then we'll be on our way. So the first thing you want to do when you have a radical equation is get the radical by itself. You want to get it all by itself so there's nothing else with it. After that, you want to raise both sides to the power of the index. So if it's a square root, you're going to raise it to the second power. If it's a cube root, you're going to raise it to the third power, so on and so forth. From there, you're just going to solve the equation. Just like you would any other equation you've done at any point in your mathematical career. The last thing you want to do is check your answers. So check your solutions in the original. Make sure you don't end up with any extraneous solutions, things that give you negatives under the radicals, things that give you zeros and denominators, that kind of stuff. So, with that said, we're going to go through a couple of examples here. Starting with number 1, we have the cube root of x minus 4 equals 0. So following along with our steps, we want to get our cube root here all by itself. To do that, you're going to go ahead and add 4 to both sides. And you'll end up with the cube root of x equals 4. The second step is you want to raise both sides here. So this side and this side, you want to raise it to the third power. Both sides are going to be raised to the third power. So the cube root of x to the third power, they cancel out and you're left with just x. That's going to equal 4 to the third power. Well, 4 times 4 is 16. Times 4 again gives us 64. So we think that's going to be our final solution right there, x equals 64. But again, you want to go back and check to make sure that you didn't get any weird things happening in your original equation. So you're going to go back and do your check, which is the cube root of x minus 4 equals 0. And we want to plug our 64 in there to make sure it works. So we're going to have the cube root of 64 minus 4 equals 0. The cube root of 64, you can use your handy-dandy calculator to figure out that that is in fact 4 minus 4 equals 0. So 0 does equal 0, and we are good to go. Second example, we can't make them all easy, so we have to have a couple that are a little tougher, like this one. So the very first thing you want to do, get that radical that has the variable under it all by itself. So you want to isolate that 4x minus 7 that's under the square root. So you want to subtract 2 from both sides. And you will have the square root of 4x minus 7 equals 5 minus 2 gives us a 3. Now the index for this is a square root, so we want to square both sides. Square that side, square that side. And the beautiful thing about that is the square root and the square cancel, so you're left with just 4x minus 7 equals 3 squared is 9. Now you're down to a two-step equation that you should be able to solve without a problem by adding 7 and you'll have 4x equals 16, and then dividing by 4, and you'll get x equals 4. So we think that's our answer, but we always want to make sure we go back and check to make sure we don't get any strange things happening. So we're going to go back to our original, 4x minus 7 under the square root plus 2 equals 5. And we're going to go ahead and plug our 4 into that. So we're going to have the square root of 4 times 4 minus 7 plus 2 equals 5. 4 times 4 is 16, so that's the square root of 16 minus 7 plus 2 on the outside equals 5. 16 minus 7 is 9, so the square root of 9 plus 2 equals 5. Square root of 9 is 3 plus 2, and that means that 5 does in fact equal 5, and we are good to go. This third one here, I'd like you to pause it for a second and try and work it out on your own, see if you can figure it out. When you're finished, unpause it, I'll go through it quickly, and then I'll move on to our final example down there, number 4. Alright, so let's see how far you got. First thing you should have done is try and isolate that radical there by subtracting 7. You'll end up with the square root of 2y minus 1 equals 4 minus 7 is negative 3. We're going to go ahead and square both sides, and we'll end up with 2y minus 1 equals negative 3 squared is 9. Add 1, and you'll have 2y equals 10. Divide that out, and you should get y equals 5. You should know whether your answer is right or wrong, though, because you obviously went back in and checked by putting it back into the original 2y minus 1 plus 7 equals 4. And you plugged that in, so you had the square root of 2 times 5 minus 1 plus 7 equals 4. So you get the square root of 10 minus 1 plus 7 equals 4, or the square root of 9 plus 7 equals 4, which gives you 3 plus 7, which equals 4, which is 10, which does not equal 4. So you'll notice that we got down to something here that told us it wasn't true. Well, that kind of makes sense, because if you take any number, when you take the square root of it and then add 7, it's never going to be 4. So this actually does not work, and there are no solutions to this problem. I know some of you probably freaked out. You tried it twice, and then you said, you know what, I'm just going to see what he has to say about it. So I'm glad that you worked it out on your own. Hopefully you didn't get too frustrated. Number 4. Again, a little bit tougher. We're going to go ahead and isolate our radical there by subtracting 1. But now what this is going to do is give us x minus 1 on one side equal to the square root of x plus 5. So when we get rid of that radical, we're going to square both sides. So now we actually have x minus 1 squared, or x minus 1 times x minus 1 equals the square root of x, not the square root, equals x plus 5, because the squared and the square root will cancel out. Over on the left here, we're actually going to have to FOIL that out. So we'll have x squared for our firsts, minus 1x for our inners, minus 1x for our outers, and plus 1 for our lasts, equal to x plus 5. We can combine some like terms. We'll have x squared minus 2x plus 1 equals x plus 5. And now we need to get it to equal 0. So we're going to subtract our x, subtract our x, subtract our 5, subtract our 5. I'm doing 2 steps at once here. Sorry about that if it confuses you. and you'll end up with x squared minus 3x minus 4 equals 0. We can go ahead and factor that out now. So we end up with x and x. Factors of 4 are 1 and 4 or 2 and 2. In this case, we're going to use 1 and 4. We want our bigger number to be negative and our other number to be positive. So when we factor t-bar that, we'll have x plus 1 equals 0, x minus 4 equals 0. So our answers are x equals negative 1 and x equals 4. And you're going to have to go back and check both of those in your original. So we want to know, is negative 1 actually equal to 1 plus the square root of negative 1 plus 5. So we have negative 1 equals 1 plus negative 1 plus 5 is 4. Negative 1 equals 1 plus the square root of 4 is going to be 2. So is negative 1 equal to 1 plus 2, which is 3? So negative 1 does not give us a true statement, so we have to go back and reject that answer. Negative 1 did not work. Go ahead and check the second one now. So we want to know, does 4 equal 1 plus the square root of 4 plus 5? So 4 equals 1 plus 4 plus 5 is 9, so the square root of 9. 4, is that equal to 1 plus the square root of 9 is 3. 4 does equal 4 in this case, so our answer, the one that works, is x equals 4. If you end up with some kind of a problem where an equation has two radicals in it, equation that has two radicals, you want to get one on each side so that you can square both sides then, and the radicals will vanish. So if you have an equation that has two radicals, you want to get one radical on each side of the equal sign. So we'll do one quick example here, and then we'll be on our way. We have 3 square root of x minus 2 minus 2 square root of x plus 8. So you want to get one of those to the other side. I'm going to suggest we go ahead and take this one that's negative and add it. So we're going to do plus 2 square root of x plus 8 plus 2 square root of x plus 8. These ones will cancel because we have a negative and a positive. So we'll be left with 3 square root of x minus 2 equals 2 square root of x plus 8. When we go ahead and square both of these, you're going to square the number in front. So 3 times 3 gives us a 9. The radical and the square will cancel. So we'll have x minus 2 equals, this should be on the outside here, 2 squared is 4. The square root of x plus 8 squared gives us just x plus 8. We're going to go ahead and solve that like a multi-step equation where we're going to distribute here. So we'll have 9x minus 18 equals 4x plus 32. 4 times 8 gives us that 32. And then we're going to subtract our 4x. I'm going to do 2 steps at once here, so stay with me. Plus 18, plus 18. 9 minus 4 gives us a 5x equals 32 plus 18 is 50. So we should end up, when we divide it out, with x equals 10. Again, we need to go back and check that in the original, though, not in that crazy thing that we did here. So we're going to have 3 times the square root of 10 minus 2 minus 2 times the square root of 10 plus 8. And we want to know, does that equal 0? So we have 3 times the square root. 10 minus 2 is 8. Minus 2 times the square root of 10 plus 8 is 18. We want to know, does that equal 0? So we need to do a little simplifying here. We know we can break that 8 down into square root of 4, square root of 2, with a 3 out in front, minus 2. 18 can be broken down into square root of 9, square root of 2. So we're going to have 3 times 2, square root of 2, minus 2 times 3, square root of 2, or 6 square root of 2, minus 6 square root of 2, which, if you have two things that are the same and you're subtracting them, that does in fact give you a 0 equal to 0. So our final answer was correct. X equals 10. I know that was a little bit longer than I expected. I'm sorry about that, but we will do some more practice in class tomorrow. Have a great night.